Hello everyone, welcome to Brain Blitz Audios. Today in this episode of Cbse board exam, we'll be looking at previous year questions of mathematics in Cbse board exams. Today we're dealing with a very important chapter, continuity and differentiability. This is the 5th chapter in the grade 12 syllabus for for maths in Cbse, and this chapter is very important. It's applied in physics as well, and it's the continuation of differential calculus from class 11. So in this chapter we'll be talking about continuous functions and discontinuous functions and the various forms of differentiation. So therefore this lesson is very important. So here we are with some very important questions which are quite lengthy, but with some tricks and tips you can score them easily as well. So this is our first question. Differentiate the following function with respect to x. Tan inverse of root of 1 plus x minus root of 1 minus x whole divided by root of 1 plus x plus root of 1 minus x. So you need to differentiate this following function with respect to x. And this question was asked in Delhi 2008. So we consider the function tan inverse of the given bracket as y. And then what we do is we let x be equal to cos theta. That means you can later write theta as cos inverse of x. So in the places of x you can add cos theta. So therefore y will be equal to tan inverse of 1 plus cos theta root minus root of 1 minus cos theta divided by root of 1 plus cos theta plus root of 1 minus cos theta. So now we have the function in the form of theta. So how do we convert this function? How do you convert this to a form where you can differentiate it easily? The best thing to do is to convert whatever is inside the bracket in terms of tan, so that tan inverse and tan gets cancelled. For that, what we do is we use these two formulas, 1 plus cos 2 theta as 2 cos square theta, and 1 minus cos 2 theta as 2 sine square theta. So therefore you have tan inverse of 2 cos square theta whole root minus under root of 2 sine square theta divided by under root of 2 cos square theta plus under root of 2 sine square theta. So root of cos square theta is cos theta and root of sine square theta is sine theta. And if you notice, across the numerator and denominator you have root 2 as common. So therefore y will now be equal to tan inverse of root 2 times cos theta minus sine theta divided by root 2 times cos theta plus sine theta. So both the roots get cancelled, and you have tan inverse of cos theta minus sine theta divided by cos theta plus sine theta as y. So now what we can do is we can divide the numerator and denominator by cos theta, because if you divide both the numerator and denominator, then it will cancel each other out, and instead of cancelling we can do other operations as well, which will give us a different form of the same function y. So y will now be equal to tan inverse of cos theta by cos theta. Well, over here we made a slight mistake, and it's very significant as well. Here we took cos 2 theta and the right hand side is cos theta. So since we took cos theta here, it'll be theta by 2, theta by 2, theta by 2, theta by 2. So just be careful with that. So take this as take this as 2 theta. So theta will be equal to dash divided by 2, like that. So over here, this is our equivalent to 2 theta. So therefore, the equivalent to theta is theta by 2 inside the bracket. So now tan inverse of cos theta by 2 divided by cos theta by 2 is 1 minus sin theta by 2 divided by cos theta by 2 will give you tan of theta by 2. And then you have cos theta by 2 by cos theta by 2 gives you 1 plus sin theta by 2 by cos theta by 2 gives you tan theta by 2. So how do we solve this? So for solving this, what we can do is we can take this one and the one that can be multiplied with tan of theta by 2 as tan of pi by 4. So that means you can write this as tan inverse of tan pi by 4 minus tan theta by 2 divided by 1 plus tan pi by 4 times tan theta by 2. So this bracket will now be in the form of tan of a minus b. Tan of a minus b is tan a minus tan b divided by 1 plus tan a into tan b. So therefore, y will be equal to tan inverse of tan pi by 4 minus theta by 2. So now tan inverse and tan gets cancelled, so y equals pi by 4 minus theta by 2. But since theta is equal to cos inverse of x, you will get y as equal to pi by 4 minus 1 by 2 times cos inverse of x. So now we got the function y with respect to x. And this form is much easier to differentiate than the one that we had earlier. So now the simple step is to differentiate y with respect to x. So therefore dy by dx is equal to d by dx of pi by 4 minus half cos inverse of x. D by dx of constant is 0 minus 1 by 2 times d by dx of cos inverse x can be written as minus 1 divided by root of 1 minus x squared. So minus and minus multiply to become plus, and so therefore you will get dy by dx as 1 divided by 2 into under root of 1 minus x squared. So therefore the value of dy by dx is this expression, and this is how we arrive at the correct solution. So one of the most important things when it comes to continuity and differentiability is to simplify the function. Let's look at the next question. If y is equal to under root of x squared plus 1 minus log of 1 by x plus under root of 1 plus 1 by x squared, then find dy by dx. This is again asked in Delhi 2008. And let's look at how we can simplify this equation first. So now we have the value of y. So what we can do is we can take the terms inside the root with a common denominator. So we take the lowest common multiple here. So y will now be equal to under root of x squared plus 1 minus log of 1 by x plus under root of x squared plus 1 divided by x squared. So under root of x squared in the denominator becomes x. So therefore under root of x squared plus 1 minus log of under root of x squared plus 1, and then outside the root plus 1, whole divided by x, gives you the expression for y. So this is how y is at present. Now, in order to make this a lot more simpler, would like to use y equals u minus v. So we made the function y as the difference between two functions u and v. All of these are functions with respect to x, so therefore on differentiation with respect to x, dy by dx will be equal to du by dx minus dv by dx. So let's start with u. U here is under root of x squared plus 1. So now on differentiation with respect to x, you get du by dx as equal to d by dx of under root of x squared plus 1. So d by dx of a value in the root will give you 1 by 2 root of x squared plus 1 times the differential of x squared plus 1. So therefore you have 1 by 2 root of x squared plus 1 times 2x plus 0. So the 2 and 2 gets cancelled. That means du by dx is equal to x divided by under root of x squared plus 1. So this is the value of u. And this is the value of du by dx. So the differential of the function u is x divided by under root of x squared plus 1. And now let's look at v. V is given as log of under root of x squared plus 1, then outside the root plus 1, whole divided by x. So dv by dx will be the same as d by dx of log x squared plus 1 divided by x. The second plus 1 is outside the root. And now let's start solving it. The first function that the derivative is dealing with is log. And for a log function, the derivative will always be 1 by x, or whatever the variable is. So in this case, it will be 1 divided by under root of x squared plus 1, and then plus 1, whole divided by x. And then you derive that part. So under root of x squared plus 1 times plus 1, under root of x squared plus 1, and then outside the root plus 1 divided by x. So over here we can rewrite the right hand side as x divided by under root of x squared plus 1, and the derivative can be written in the terms of d by dx of u by v, that is the division. This is the division scenario, so you will have x times d by dx of under root of x squared plus 1 minus under root of x squared plus 1 times dx by dx, and then the denominator will be squared, so x squared. So now what we get is dv by dx can be written down as x divided by under root of x squared plus 1, and then plus 1. Let's erase the other marks over here and then write that again. Now the differential in the differential using the quotient rule can be written down as x times, if you look at d by dx of x squared plus 1, you will get 1 by 2 root of x squared plus 1 times 2x. So then we take the minus, so that is x under root of x squared plus 1 and then plus 1 times dx by dx, that is equal to 1 whole divided by x squared. So over here, what we're going to do is we are going to cancel out the 2's, and then it becomes x squared divided by under root of x squared plus 1 minus x squared plus 1 under root and then plus 1 whole divided by x squared. So now what we get is we get dv by dx as equal to x divided by under root of x squared plus 1 plus 1, and now what we do is to take under root of x squared plus 1 common on the other side, so what we get is x squared minus x squared plus 1 times under root of x squared plus 1. So basically we multiplied we multiplied the numerator by under root of x squared plus 1, and the denominator also is multiplied with it, so x squared times under root of x squared plus 1. So now let's write down that earlier equation, dy by dx is equal to du by dx plus dv by dx. So therefore now you can write dy by dx as x divided by under root of x squared plus 1 minus x divided by under root of x squared plus 1 and then plus 1 instead of doing that, what we can do is we can simplify here as well. So we cancel out x in this numerator, which cancels out x squared to x, so it makes x squared as x. So therefore you will have the following equation. So you'll have 1 by under root of x squared plus 1 plus 1, and then inside the bracket you will have x squared minus under root of x squared plus 1 times under root of x squared plus 1 the whole divided by x squared times under root of x squared plus 1. So now basically we will multiply under root of x squared plus 1 to the bracket, so x divided by under root of x squared plus 1 minus 1 divided by under root of x squared plus 1 plus 1, and then inside the square bracket you will have x squared minus this x squared plus 1 under root and this x squared plus 1 under root will multiply together to give you x squared plus 1, but then if you open the bracket it will be minus, so minus x squared minus 1, and then you have minus of the root of the same. So x squared minus 1 minus under root of x squared plus 1 is the numerator, and the denominator is x squared times x squared plus 1. So now let's take the denominator outside the bracket towards the bracket. So what you get is x squared and x squared gets cancelled, and then now you have minus under root of x squared plus 1 minus 1 divided by x times under root of x squared plus 1 times under root of x squared plus 1, and then outside the root another plus 1. So in both of these terms, 1 by under root of x squared plus 1 is common, so dy by dx can be written down as 1 by under root of x squared plus 1, and then inside a square bracket you write x and then plus minus of under root of x squared plus 1 minus 1 can be written down as x squared plus 1 and then plus 1 whole divided by x of x squared plus 1 under root, and then outside that root you have a plus 1 as well. So now what you can see is that the under root of x squared plus 1 is now present on both the numerator and denominator, so you can cut it out. So basically what you get is 1 by under root of x squared plus 1 outside the bracket. Inside the bracket it's x plus 1 by x. So therefore 1 by under root of x squared plus 1 times x squared plus 1 divided by x. But then you can now cancel this numerator with that denominator to get under root of x squared plus 1 divided by x as the final equation of dy by dx. So therefore, by using the correct substitutions and the correct transitions, you have got your correct answer, that is under root of x squared plus 1 divided by x. Let's look at the final question for this episode. This is a very important question. It's a higher order thinking skill question asked in Delhi 2008. And it says, if y equals cot inverse of under root of 1 plus sine x plus under root of 1 minus sine x whole divided by under root of 1 plus sine x minus under root of 1 minus sine x, and 0 is less than x less than pi by 2, then you have to find the value of dy by dx. So in this question, we have the function written down as y equals cot inverse of the given bracket. And how do you simplify that bracket? Simplifying this bracket is the most important part here. Now, if you look at what is inside the root, it is 1 plus sine x. Now, we know the general formula, 1 plus sine 2x, can be written down as cos x plus sine x, the whole squared. So basically what we did is we took 1 as cos square x plus sine square x, and sine 2x as 2 sine x cos x. So cos square x plus sine square x plus 2 cos x sine x will give you cos x plus sine x the whole squared. So this equation holds. Similarly, 1 minus sine 2x is equal to cos x minus sine x the whole square, using the same substitutions. Now, if you noted this formula, in this formula I've written cos x plus sine x, and this is due to the fact that our limit for x is between 0 and pi by 2. So in that case, it will be cos x minus sin x the whole square for the function 1 minus sine 2x. If x was higher than pi by 2, then what would have happened is that sin x would have been positive and cos x would have got the minus sign. So it would have been sin x minus cos x the whole square. So now we have these general equations. Mind you, they're general equations. You need to substitute that. So here it's x instead of 2x. So therefore y has to be equal to cot inverse of cos x by 2 plus sine x by 2 the whole square, which is inside a root, and then plus under root of cos x by 2 minus sine x by 2 the whole squared, and then you take the denominator, and the denominator can be written as the same way. So cos of x by 2 plus sine of x by 2 the whole squared under root, and then minus of under root of cos x by 2 minus sine x by 2 the whole squared. So the square and square root cancel each other out, so therefore you will have cot inverse of cos x by 2 plus sine x by 2 plus cos x by 2 minus sine x by 2. If you look at the denominator, you will have cos x by 2 plus sine x by 2, and then minus of cos x by 2 minus sine x by 2, which we can write it as minus cos x by 2 plus sine x by 2. So as you can see in the numerator, sine x by 2 and minus sine x by 2 is canceling each other, and in the denominator cos x by 2 and minus cos x by 2 are canceling each other. So therefore y will be equal to cot inverse of 2 cos x by 2 divided by 2 sine x by 2. So over here 2 is common, so it gets cancelled. So you have cos x by 2 and sine divided by sine x by 2. Cos theta divided by sine theta gives you cot theta, so therefore y will be equal to cot inverse of cot x by 2. So cot inverse of cot x by 2 will give you x by 2 as y. Now you need to find the differential derivative. So here dy by dx is equal to 1 by 2 times dx by dx. d by dx of x is 1, so therefore in this question the value of dy by dx is equal to 1 by 2. And that's all, folks, for this episode of Cbse board exam. We hope you found this episode interesting. For more useful and interesting content, don't forget to subscribe to our channel, which is Brain Blitz Audios. So until the next webisode, take care, stay safe, bye-bye for now.